Okay, so just a few things about your lab write-up. We will leave the sources of error until we see each other, but I just want to make sure there are a few things clear if you work on this before I see you again. Okay, so the purpose, the materials are here. You made the prediction for your hypothesis. Remember, you're going to rewrite the procedure so it's past tense and impersonal. So you would say the ring stand was connected together and the extended clamp was placed on it. One of the 4 hanging clamps was hooked over the knob of the extended clamp. The meter stick was slid through the clamp so that it was balanced. Once it was balanced, the clamp was tightened. Now, be careful with this. And some of you abbreviate way too much. Okay, you got to pretend like there's an unphysics person that's going to pick up your procedure and follow it. So you can't cut out a whole bunch of steps because they won't have a clue what they're doing. But you need to be careful on the verb hang. So hang 100-gram weight on one of the hanging clamps. You would say 100-gram weight was hung, not hanged. That's what you do with a person, but hung is what you do with an object. So 100-gram weight was hung from one of the hanging clamps. Okay? Just a couple of comments about back here. So you do need to switch your distances to meters, your masses to kilograms. You're going to get this final column by adding these two up, okay? And it's this final column that you're going to use in your calculations, okay? It's not just the 100 grams, it's the clamp plus the weight. All right, and so in question number 1, all your calculations are laid out in the questions. So question number 1 was experiment 1 in rotational equilibrium. Using your data, confirm this mathematically. What it means by that is it wants you to do sum of the torques. It's be good if I had a pen. So you're going to do sum of the torques is equal to 0, right? So on one side, here's your pivot. On one side you had your 100-gram weight, and on the other side you had your 200. And so it'll be the torque of the 100 minus the torque of the 200 would equal 0. The torque of the 100 is R100 FG 100 sine theta 100 should be equal to R200 FG 200 sine theta 200. If you had it balanced right, the sine theta should be 1. So this is R100 M100G is equal to R200 M200G. So you're trying to confirm, is it in equilibrium? So fill in the R you got for the 100 weight. Fill in the actual mass plus its clamp for the 100, 9.81. Do the same on the other side and see how close they are to each other. If they are really close together, then yes, it's in rotational equilibrium. If they aren't, then it means that you didn't do a great job balancing it. And then you should say they do not appear to be clearly, we must have made an error in balancing it or measuring it or so, okay? And number 2, and number 3, and number 4, it's asking you to find the mass of the unknown. So you're going to do the sum of the torques again. So for the first one, it'll be the 100 minus the unknown, or vice versa. So R100 FG 100 sine theta 100 minus R of the unknown FG of the unknown sine theta of the unknown. Again, your thetas should be 90, so these should go to 1. So R100 M100 G should equal R of the unknown M of the unknown G. And you're solving for M of the unknown. And again, this is going to be the actual 100-gram mass that you weighed plus its clamp. And so when you get the answer here, it's going to be your unknown plus its clamp. But you only want the unknown. So once you get this, then you need to do minus the mass of the unknown's clamp. Why? Because the question asks you, what is the mass of the unknown? It doesn't want the mass of the unknown plus its clamp. Okay, so don't forget to subtract the clamp off. And that's why, one of the reasons why you had to keep track of which clamp was which. You're going to do the same thing for the 200 on the unknown and the three of them together. Then when you get to number 5 wants you to do percentage error. So you're going to do the percentage error for the 100 in the unknown, the 200 in the unknown, and then the 100, 200 in the unknown. So you're going to do it for your results from 3, 4, and 5. So remember, percentage error is theoretical minus experimental over theoretical, and of course it's the absolute value, times 100. Your theoretical is what we measured off the balance, and your experimental is what you got up here. Okay, and you're just doing it for the unknown, not the unknown in the clamp. Okay, so you're going to do this 3 times, once for each of them. All right, and like I said, we'll talk about sources of error when I see you again, but I just want to go through the calculations for those of you that would be working on it before I saw you again. All right.